Guys, chance to kind of try these. Let's go ahead and work on these together here. Number one, can you see how number one is truly a multiplication? So notice right here, there is no symbol, right? There's no symbol between that negative 9t to the 7th and the parentheses. Like there's no symbol there at all. So in math, when there's no symbol, listen, when there's no symbol, it's understood to be multiplication. We do this all the time, right? Like if I said, well, think about this. We use guys, listen please. Hey, stop doing all the little communications. Pay attention. Please. We do this all the time. Like if I said, hey Bree, are you having a great day? And her response is silence. Isn't she really telling me something with her silence? Yeah. So in math, silence, like when there's no symbol at all, it's still telling us something, right? It's telling us that the symbol should be or could be multiplication. So I would think of this as negative 9t to the 7th times, I tried to put a little dot in there, times negative 5t to the 4th. Does anybody have any idea what this is? What do you think, Kate? It's actually not a distributive property. Doesn't the distributive property look like A parentheses B plus C? Like the polynomial in the parentheses would need to be at least a binomial, right? So if you saw, this would be, Kate, that's actually my favorite comment so far today. This is good. If I wrote this, do you all see how this is the distributive property? Right? Whereas the original isn't. So let's keep going. What do you think this would be? I'm wondering if any of you has thought of an answer here. Hey, and Bray, your packet should be out in front of you. Sasha, your packet should be out in front of you. Please don't make me do this. Go ahead. Chase.
45t to the 11.
So Chase got 45t to the 11th. What do y'all think about that as far as an answer? That's totally awesome. It's right on the money. So Chase, did you multiply the negative 9 times the negative 5 to get the 45? And then you said t to the 7 times t to the 4th. There's 11 of them, right? 7 and 4. 7 plus 4 makes 11. That's right on the money. Nice work. Nice work. Okay, thank you, Chase. Did anybody try number 2? Sebastian, what do you think about number 2? Kate, is that the same thing you got, or did you get something different? I'm so glad, because you're both right. Perfect. I just want to see what you all had to say. That's perfect. So there are 6 x's being multiplied together, right? There's 2 of them, 3 of them, 1 of them. That makes 6. And then 6 times negative 3 is negative 18. Honestly, if you can do this repeatedly, you're going to be able to do everything we're going to do today. Seriously. So I'm feeling encouraged because you guys have had some really good answers so far. Okay. So let's take a look at 3 and 4. This is a nice little setup here. I think you guys know this. I've been teaching some kind of Algebra 1 in some form or another for a really, really long time. In fact, 21 years now? 21 years. So can you imagine, I've seen fads come and go. I've seen good, I've seen bad, everywhere in between, right? So I just wanted to let you guys know, the method we're going to use today, I think, is pretty awesome. It might be different from what you did in middle school. Let me explain why we use this method. For the first about 15 years of me teaching Algebra 1, I had students, we would do this same kind of thing every year, and there'd be like, some people would get it right away, other people wouldn't, and some people would really, really struggle, and it was just kind of this mixed bag, and we have to really work at it. About 5 years ago, came across this method. We call this the generic box method, or just the box method. And it went from students, having some struggles and challenges, maybe a few getting it right away and that kind of thing, to very quickly people getting it. And not only that, we're kind of building towards the future as well. So basically just by trying it out and saying, whoa, that actually worked really good, I've been convinced that this is a great way to do it. So some of you might have done questions like what we're going to do today. Some of you might have even used some different methods. It's very possible. I'm going to ask you to give this a fair hearing and a fair shot. Like if you know how to do this and you know how to do it, I don't really care what method you use. But if you look at this, you're like, I don't have any idea what to do with this. For goodness sake, use this method because it works really, really well. So here we go. The first one, number 3, is I am multiplying a monomial, and I'll highlight the monomial for you. The monomial is highlighted in green. I'm multiplying a monomial times a binomial. And isn't this kind of like what Kate identified earlier as the distributive property?
Yep.
It kind of is a distributive property. These can get kind of complicated, as you can see in number 4. So I want to show you this generic box method, or I'll just call it the box method. Here's how it works. Take your first factor, which is 7t to the 8th, and write it out there to the left of the boxes. And then take your 2 terms of the binomial, the parts that are in the parentheses there, and write those up here and here. So 2t to the 5th and positive t to the 4th. And then all you really need to do here is multiply to fill the boxes. So I would multiply this times this to get that box. So, anybody have any ideas on what 2t to the 5th times 7t to the 8th would be? 14t to the 13th power. Right on the money. And then, of course, to get this second box filled, I need to multiply those two together. So, Noah, what do you think? T to the 4th times 7t to the 8th is? 7t to the 12th. That's right. So then our final step would just then be to write this off to the side. 14t to the 13th plus 7t to the 12th. And that'd be our final answer. So somebody might say, well, gosh, Mr. Anderson, couldn't we just do the distributive property? I'll be really pragmatic about it. Like if you can do this, if you can do number 3 with the distributive property, no problem. Do you see how number 4 gets more complicated? And wait until you get to numbers 5, 6, 7, 8, ... They're going to get even that much more complicated. That's where the box method becomes even better. So number 4, and the beauty of this, I guess, is that it's consistent. You always do the same thing. So check out number 4. Negative 9x squared goes there. 6x cubed plus x squared negative x positive 3. You just fill in all the spaces to the left and the top. Anybody ever done it like this before? Oh, this is so good. This will really help us when we get later on to something called factoring. It'll really, really help. Okay, so let's just hear what you have to say. Sophia, what about the first box there? What do you think should go there?
Negative 54x to the 5th.
She's right, isn't she? Nice work. Excuse me. Isa, how about that second box?
Negative 9x to the 4th.
Fantastic. Perfect. Any volunteers for the third box? Ella, what do you think?
9x to the 3rd.
Positive 9x to the 3rd. Right on the money. Anya, what do you think about the last box?
Negative 27x to the 2nd.
Yep, negative 27x squared. Yeah, that's perfect. Okay, you guys are, I don't know, I hope you trust that I'll be honest with you. You guys are doing great. Keep it up. It's really, really good. So my final answer here, I'll just write it outside the box, would be the customary way to do this. Negative 54x to the 5th minus 9x to the 4th plus 9x cubed minus 27x squared. Okay, and that'd be our final answer. Put it in a box. We're done. Any questions so far? So far we've multiplied a monomial times a binomial, and then a monomial times a 4-termed polynomial, right? So when you flip the page over, which I encourage you to do, this is where you're going to start to encounter some others that are a little more interesting.
Oh my gosh.
So why don't you guys, let's do it this way. I think you guys are totally ready to do number 1 on your own. So why don't you just take a brief moment here and see if you can handle number 1 all by yourself. And then we'll tackle number 2. Number 1 is 3x squared parentheses x minus 7. It's a monomial times a binomial. So again, I hope you hear me well. Like when I show you a method like the box method, I hope you don't hear me incorrectly. I am not telling you that the only way is to do the box method, or everyone thinks the box method is the best. I'm only saying, in my experience, It's been a great method. It's worked well. All right. Anyone think they have the complete answer for number 1? Complete answer. What do you think, Ray?
3x to the third minus 21x to the second.
You guys agree with him?
Yes.
I hope you do. He's got it right. Nice job. Very good job. Okay. Let's take a look at number 2. Does anybody notice anything different about number 2 as compared to all the other ones we've done so far?
It's not this primitive.
Technically somebody could call it a distributive property, but I agree it's not like the normal look. What do you think?
It's like 2 binomials.
Instead of a monomial times something, it's a binomial times something. In this case, it's a binomial, right? So this is a little bit different. So what this means, very simply, is that our box is going to have to look a little bit different. So check this out. The box would look like this. And since it's a binomial times a binomial, it'd be, listen please, it'd be a 2 by 2 box instead of a 1 by 2 or a 1 by 4. So let me just say a word about this. Listen please. This is where, if you've ever had any sort of an algebra class, listen. You might have heard the word FOIL to go along with something like this. FOIL is neat and everything, but when you're doing a binomial times a trinomial, FOIL falls apart. It doesn't work anymore. Seriously, when you're doing a trinomial times a 4-termed polynomial, FOIL, inconsequential. FOIL only works for a binomial times a binomial. And to be honest with you, FOIL doesn't really help a whole lot when you're trying to factor. It really doesn't. So again, I would encourage you to think about this. This is going to make me sound really old. You are still 6 years away from being born, and I was teaching algebra. AKA, I've been doing this for a really long time, and I found that this box method works well. Okay? So trust me or not, it's up to you. So here's how this would work. We're going to fill in the outsides of the box just like we did before. I'm going to go 4x squared minus 3 and 5x plus 1. Okay, so just like we filled in the outer edges of the box before, now it's a 2 by 2 multiplication instead of a 1 by 3 or something like that. It's a 2 by 2. The beauty of this is the method we use to get all the insides is the same method we used before. So if I want this upper left, this first box, I just multiply the 4x squared times the 5x. Anybody know what that is? 20x. Yeah, 20x to the third. You got it. Good. Okay. 20x to the third. Then this upper right box would be 4x squared times 1. It's 4x squared. Lower left. That's right. I think I heard Sebastian say negative 15x. I agree with that. And then how about that last lower right box? What's that one going to be? Minus 3. Yeah, negative 3. So then all we have to do now is take this and write it in descending order, and we've got it. So please don't just leave your answer in the box. Just take a second and copy it over like so, right there. By the way, it's a 4-term polynomial, right? What's the degree of our final answer? Degree 3. What's the lead coefficient? 20. Good. So since it's 4 terms, it doesn't have a special name.
So on the test, when you solve these, do you want us to put the degree in the code?
Only if I ask for it. So yeah, you don't really need to. I'm just doing that for a review, just to kind of freshen up from what we did a couple days ago. Yeah. All right. You guys hanging in okay?
Yes.
Okay. So let's see what we're going to do next. Yeah. So look at number 3. 3 is one we did on the other page. So why don't you guys try 3 all by yourselves? I'll give you a minute or two here to do number 3. Number 3 is a monomial times what? Monomial times trinomial. So if you're going to do the boxes would be 1 by 3, right? Monomial times trinomial means 1 by 3 box. maybe you can see number 4 coming up is a binomial times a trinomial. That's not going to be a 1 by 3. It'll be a 2 by 3. We'll get to number 4 in a second. Doc, I keep thinking about what you said earlier about Friday last period. You guys are ultra sharp today. Actually, I'm thinking this is the right time.
Yeah.
You guys are doing great. Okay, anybody want to volunteer the complete answer for number 3? What do you think, Anya?
6x to the 5th plus 24x cubed minus 30x squared.
She said that really fast, and I think I got it up there correctly. Bray agrees with Anya. Does anybody else agree with that?
I agree with that.
I'm feeling really encouraged. Issa's with you guys. Yeah, that's it.
You don't agree with that?
Oliver, how many terms are in that final answer? 3 terms. So as far as a special name goes, what would we call this one? Trinomial. Okay. So this is a trinomial. Caroline, what's the degree of this trinomial?
I don't know. Wait. 10?
Say again?
10?
10? Where are you getting 10 from?
I don't know. I added the exponents on.
Oh, okay. So isn't she right that it has to do with the exponents? It definitely has to do with the exponents. So she added them all up. What should she be doing? Looking for the largest exponent. So what do you think the degree is?
5.
5. Yep. So degree is 5. Doc, how about the lead coefficient?
6.
Okay, that's right. Still doing okay? I totally think you are. Okay, so number 4. So this is a nice contrast. Number 3 is a 1 by 3 multiplication. Number 4 you can see is going to be a 2 by 3. So I'll take a minute and try to build the boxes up here. You do the same thing, and we'll see how all this turns out for number 4. We'll finish in a really good spot, I think. Trevor, you got this one down? So let's see here. So does your 2 by 3 look like that? Okay, so let's we'll go through this step by step. I'll just color code it. What do you think the green box should have? What do you think, Sophia?
X to the 5th.
X to the 5th. Okay. Any takers on the red box? What do you think the red box should be? Negative 2x cubed. Agreed. All right. How about the orange box there on the very end, Bray?
8x.
8x. That works. 8 times x. Positive. Yep, that's correct. Okay. How about the light blue box? What do you think that should be? Issa, what do you got?
3x to the 4th.
Okay, 3x to the 4th. How about Bree? How about the yellow box?
Negative 6x to the 2nd.
Okay, negative 6x squared. And then lastly, the blank box. Okay, 2, 4. Yep, that makes sense. All right. Final step here would then be to just add these up in the customary way. So it'd be x to the 5th plus 3x to the 4th, 2x cubed. I got it all in there. Okay. So what I have out here inside the box, that black box out there to the right, this here would be your final answer. We're just using the box to get organized. Hey, can I show you the alternative?
Yeah.
So, remember how I mentioned that FOIL thing before? I just want you to see, and I hope you agree with me here, the box method is better organized because this is what it would look like if you didn't use the box method.
Oh, that's so.
Can you see how students in the past might have looked at that and thought, whoa, there's lines going everywhere? And it's totally, listen, it's totally doable to do it that way. It's totally doable to do it that way. Again, I don't want you to hear me wrong. Listen, I don't want you to go home and say, my teacher told me that my way is dumb. That is incorrect. That is not what I said. As you can imagine, like I've probably, like if you have a middle school teacher that showed you a way, can you imagine I've probably seen it?
Yeah.
And I've seen all kinds of varying successes, right? Ups and downs and all over the places. But the people that have struggled the most, they've struggled with organization. I'm not done yet. Don't pack up yet. Okay, that's totally fine. They've struggled with organization. And can we at least come to a common agreement that the box method is organized?
Yeah.
Say what you want. You can say, well, it's not as fast as my way. That might be true. I don't really care. But is it super organized? I say yes. So that's the goal. That's the goal. Okay, so the final one might be the most challenging.
I got it.
So before we do any boxes of any kind, we have to be really careful. Listen now, we have to be very careful that we understand what we're even doing. And if my screen would come back, it would be lovely. We'll see. So you guys see on your papers, right? Look on your papers. Oh, there it is. 2x minus 3 in parentheses squared. Listen now, what does squared really mean? Multiplied times itself. That's right. So what I really need to do here, and this is super crucial, please don't look at this as like a unnecessary hindrance. What you need to do is you need to write this out. Listen now. Write it out for what it really is. Are you watching? So isn't 2x minus 3 in parentheses squared really this?
Yes.
I really think that you should write that step down. Can I show you a common error? I'll put this up here. What I'm about to write is wrong. I'll put it in red. I've seen plenty of people tell me that this equals 4x squared, either minus 9 or maybe plus 9 or something like that. This is a very common error, and this answer is wrong. Okay? And you're about to see why here in a second. So this down here, isn't this a binomial times a binomial? So what kind of box would you use? 2 by 2. Yeah. So I'd come down here and say, all right, I'm going to do my 2 by 2 box. And I've got 2x minus 3 times 2x minus 3. So let's see if we can fill in the boxes. Chase, how about the yellow box? What do you think that would end up being?
4x to the square.
Correct. 4x squared is right. Okay. Trevor, what do you think about the purple box?
Negative 6x.
That's right. Ella, what do you think about the blue box?
-6x.
That's right. And then anybody? How about the final box, the white one?
9.
Plus 9. Okay, so just 9. Here's where this gets maybe interesting compared to what we thought. 4x squared minus 6x minus 6x plus 9. Do you all see how the purple box and the blue box are actually like terms?
Yeah.
So what's negative 6x minus 6x?
Negative 12x.
So our final answer would be 4x squared minus 12x plus 9, which is not that thing that I showed you earlier. A lot of people think that it's this. You can see that you clearly missed that middle term, right? Let me wrap it with this, guys. My final answer is right here in the purple box. This is my last chance to do this, so please try hard. That polynomial has a special name. What is it? It's a trinomial. What is the degree? Degree is 2. What's the lead coefficient? 4. With that, I say goodbye. Great job. Have a wonderful weekend. Thank you. Great job, you guys.
Mr.